Right, this is bringing back some memories. We're going to do some work on connected rates of change. So I'll go over two examples, and then I've got a sheet which is just looking at the algebra to start with. And then we can look at forming differential equations from rates of change, which is applying them to real life situations. They nearly all will involve either an area, possibly a perimeter or a volume, so that tends to be the context of the question. So I've kept my examples similar. And all we're doing is using that connected rates of change. So they're behaving like fractions, even though they're not fractions. And we're using the chain rule. So if you remember, chain rule, so dy dx is equal to dy dt times dt dx. So in a sense, these two cancel off with each other and take you back to dy dx. That's all we're using. So this example here, a is pi r squared and dr dt is 2. This is your rate of change. This is how quickly the radius is changing with respect to time. But we'll come into this as we go on. And we want to find how quickly the area is changing with respect to time when r is equal to 3. So your first step is nearly always, I'm not guaranteeing this, but nearly always you need to differentiate the area or the volume with respect to the variable it's defined by. So I need to differentiate A with respect to R, which gives me 2 pi r. And then I want dA dt. So I need dA on top. And then if I multiply this by dr dt, so the dt is underneath, then these will cancel off and take me back to there. So dA dt is equal to 2 pi r times 2, which is equal to 4 pi r. And so when r is equal to 3, A, dA dt even, is equal to 4 pi times 3, which is 12 pi. I'll do one other example. This example is actually on the worksheet that I'm going to give you. So this one, we're going to start with a volume. I'll just check that's in the right place. Right, so we'll start with a volume. So V is equal to 8 pi r cubed, and this time the rate of change, sorry, that's meant to be a V, the rate of change of the volume with respect to time is equal to 14. This doesn't have to just be a number, they just happen to be in this example. And we want to find dr dt, so the rate of change of the radius when r is equal to 4. So I'm going to differentiate the volume with respect to r, because that's the variable it's defined by. So that gives me 24 pi r squared. And I want dr dt I've got the wobbly board here. And so I don't want this to V on top, I actually want the dr on top. So I need to do dr dv times by dv dt. So it's just linking them together. And then the dv's cancel off, leave you a dr dt. So the two sides are equal. dr dv is 1 over dv dr. So this is 1 over, we didn't have to do this on the last example, 24 pi r squared times dv dt which is 14. So you can also use special case of chain rule and do 1 over dVdr, is dr dv. That gives you 7 over 12 pi r squared. And so when r is equal to 4, dr dt is equal to 7 over 192 pi, and just leave your answers in exact form. So if you could start by working through the sheet, I think it's called Connected Rates of Change, but I'll put it in your folder anyway.